method of proving things, basically, right? So far we have proved things using combinatorics, using algebraic manipulation, binomial theorem, and many other ways. So basically counting techniques. Induction is another way of proving a certain idea or solving a certain problem, all right? So when we talk about induction, it's kind of similar to the idea of recursive algorithm. In fact, the idea of recursive algorithm stems from induction itself, all right? So think about the process of climbing a stair. If I ask you, prove to me that you'll be able to climb a stair with n steps, n number of steps, all right? How would you do that?
1 to n,
You will climb
like I
every
will
single
walk
step.
from.
So
Yes,
let's
ma'am.
say there
Oh,
are, for let's say 100 steps, let's say a
yes, ma'am.
staircase which has 100 steps. I want you to prove to me that you are able to climb the entire staircase. What would you do? Climb from step 1 up to 100.
Um,
Basically walk up the stair and show
yes,
that
ma'am.
step 1 থেকে 100 পর্যন্ত I've walked all the
Yes, ma'am.
steps,
Yes,
all
ma'am.
right?
100 এ গিয়ে পরে থেমে যাবে।
Yeah,
Yes, ma'am.
okay, fine. What about when n is equal to 1000? You will climb 1000 steps of stairs to show that you can climb these 1000 steps, that you're capable of climbing these 1000 steps. What about when n is equal to 10,000? What about when n is equal to 100,000? Tumiki, will you walk through 100,000 steps to just to prove that I am capable of counting? Sorry, I'm capable of climbing all of these steps. I'm capable of climbing the entire staircase. Would you do that?
দুঃসাধ্য হয়ে যাচ্ছে।
Just give up at 100.
Sorry, come again?
Yes, generalize করব তাহলে যে if all the steps are like similar and I can like climb up 1 or 2 steps, then theoretically I should be able to like climb up the rest of the way.
Yes.
Like
You are
I can
heading in
say
the right
something.
Yeah.
I can say something like, I will climb up the first step that is in front of me until there are no steps left. So, yeah,
Okay.
it does not matter the value of n. Just I have to just see that the next step I have to climb it, and
Okay.
that
Yeah,
is-
you guys are heading in the right direction. Yeah, that's quite about the right idea. So, in fact, even for dominoes, are you guys familiar with the domino effect? What happens with dominoes? Not the pizza place. I mean, dominoes. Like
yeah, you
Yeah.
topple one and all the others.
exactly, all the others topple. How does that work? How can you prove that you have a certain arrangement? How can you prove theoretically that the domino effect will go through the entire series? That is, all the tiles will be toppled. All the tiles will be toppled. How would you prove that? Think about it. Would you just topple one and show that, okay, all of them are toppled? And how many times would you have to do that? What happens when there are 10 tiles? What happens there are 100 tiles? What happens when there are 10,000 tiles? All right.
এন্টার পর্যন্ত যেতে পারতেছি।
So based on what some of you guys said, we are heading somewhere in the right direction. See, think about the staircase. Okay, so if I have n number of steps, any n number of steps in a staircase, I don't actually have to climb every single step to show that I can climb the entire staircase, that I am capable of doing this.
I just have to climb one.
No, not just one. I have to climb the first step, show that, okay, I can climb the first step. That is the basis of the proof, okay? Just first step to climb korte parte hobe, the basis of the proof. I can climb the first step, and then I have to show that if I can climb any given step in the staircase, je kono jaygaয় je kono ekta step jodi climb korte pari, based on that assumption, assuming that I can climb any one step in this entire staircase, I have to prove that I can climb the next step as well. What one of you guys said, okay? First I have to prove that I can climb the first step. প্রথম স্টেপটা নিতে পারি এটা দেখাতে হবে, যে ফার্স্ট স্টেপ উঠে দেখালাম যে I can climb the first step, and then I have to show that assuming that I can climb any given step in this staircase, I have to prove next that I can also climb the next step. First, I have to prove that I can climb the first step. Second, I have to prove that given I can climb any one of the steps, any one of the steps in this entire staircase, I can also climb the next one. I have to prove that I can also climb the next one. So এই দুটা জিনিস just prove করতে হবে. Think about it. If I prove just these two things, n এর value যত হোক না কেন, whatever the value of n, it by default proves that I can climb the entire staircase. Why? Because if you prove you can climb the first step, you have climbed the first step. And then what is the second proof? Second proofটা কি? Second proofটা হচ্ছে গিয়ে assuming you can climb any one step in the entire staircase, you have to prove that you can climb the next one as well. If you can prove that, এটা যদি prove করতে পারো, that means you first stepটা তো climb করতে পেরেছো, you prove that. By combining that with the second proof, দোনোটা proof combine করলে, you climb the first step, it means that you can also climb the second step. Why? Because the second proof tells us, if we can prove the second part tells us that if we are at any given step, we are capable of climbing the next step. So if you're in the first step, you're capable of climbing the next step, which is the second step. If you're in the second step, you're capable of climbing the next step, which is the third step. If you're in the third step, you're capable of climbing the next step, which is the fourth step. So you see
n স্টেপে যেতে পারলে n+1 এর
Recursion.
স্টেপ ছিল।
Yes, exactly. If assuming that we are in any given step, let's say k, let's call it k, kth step e achi, k number step e achi, we are in assuming the second proof, I'm talking about the second part of the proof. The first part of the proof is proving that I can take the first step, I can climb the first step. That is the first part of the proof. The second part of the proof is that given that I am situated at some kth step, k number step e achi, I have to prove that it's also possible for me to climb the k+1th step. All right, the next step. So first কি proof করলাম যে আমি first step এ climb করতে পারি। Second কি proof করলাম, if I'm at some k step, I can also climb the k+1th step. It means that if I'm in the first step, it by default means I can climb the second step. So by default, the fact that I can climb the second step is proved by combining these two proofs. If I can climb the second step, I'm in the second step. It by default proves that I can climb the next one, which is the third. If I'm in the third one, I can climb the fourth one. If I'm in the fourth one, I can climb the fifth one. And so on. The entire staircase, for the entire staircase, this proves that I can climb the entire staircase, right?
Ma'am, I have a question.
Yes?
I mean, why can't I just make this a bit more efficient? Like for the proof, you said there are two parts to it, like the first step and the next step. But like, why can't I say something like this, that I should be able to climb the step that is in front of me? Like if I say that, doesn't it combine all the first step and the next step?
Yeah, you should be able to climb the step that is in front of you. Yeah, you're correct. That is being broken down into two of these proofs, all right? Why are we breaking it down into two proofs, two parts? Why are we breaking that proof down into two parts? So that it's applicable in a generic way, okay? So if you think about it, I should be able to climb the next step, okay? That's correct. But next step from where? From where? Where are you standing? Next step from where? The next step in front of you, but where are you? Right? Next step in front of you, you should be able to climb that. Let's say the step after the fifth step is the sixth step, right? So if you are at the fifth step, you should be able to climb to the sixth one. Next step maniki, if you are at the fifth step, what does it mean? It means that the next step in front of you is the sixth step. You have to proving that I should be able to climb the next step means that I should be able to climb the sixth step. But fifth step e je acho, who will prove that? Based on what hypothesis did we get to the conclusion that we were able to climb the 5 steps before this? বুঝাতে পেরেছি? The next step in front of me, fine. The next step in front of me. But next step e যাওয়ার আগে তুমি currently যে step e আছো, how did you climb there? How did you go there? All right.
It's like to keep record of all the steps I've taken.
the basis, basically. This is the foundation. The foundation is what? The foundation is proving that you were able to take the first step. That is the foundation. And
So
then,
basically from step 0 to step 1.
yeah, from the
Like
first
if
step,
I say the ground as this.
the value for the lowest value, for the lowest value, 0 or 1, whichever it is, usually for 1. For lowest value, from 0 to 1, yeah. In most cases, 0 to 1. That is the first step. The first step, if you can show that you are capable of doing the basic step, and then in the inductive step, what do you prove? Inductive step bolte ki bujhai? Inductive step e amra proof kori what you said next, that I am able to count the next step. Sorry, I am able to climb the next step. First, you have the basic foundation, that is you can climb the first step, and then you have to prove that you can climb the next step. Combining these two, only by combining these two, you can say that you can climb the entire staircase, not just by saying that I can climb the next step. Because if you're talking about the next step, the step that you're currently on, how did you get there? Next step jodi bolo, acha tumi bolte paro je ami 6th step ki count mane climb korte parbo kina. In order to climb the 6th step, you have to be currently in the 5th step. How did you climb the previous 5 steps? So that's why basic step ta proof korte hobe, right?
So basically, ma'am, yeah, I can climb, but to exactly know where I am, like I have to have a starting point. So that's what you mean, I guess.
Yeah.
I need to keep track of
like-
where I am too.
More like where you are, how did you get there? More like that.
মানে বেস কেস একটা
হ্যাঁ, base case যে আমি যেখানে আছি, how did I get there? You have to also prove. You cannot just by default assume that আমি যেখানে আসছি I automatically came there. You have to have a basis of that assumption. How did you get there? Okay, you got there because you were able to climb the first step. Now, because you were able to climb the first step, and then in the inductive step, what did you prove? You proved that you're able to climb the next one. First step climb korte paro and next step climb korte paro. এই দুটাকে combine করে আমরা কি বলতে পারি? যে আমি যদি first step climb করতে পারি, by default I can climb the second step. So, since I can climb the second step, it means that by default I can climb the third step. Since I can climb the third step, by default I can climb the fourth step. And see, it builds on top of it like that. Okay.
So that is
Just based on
induction.
previous steps. So that is induction, exactly. That is induction. And this induction is used to prove so many identities. You will, I don't know if you do that in this university, but in algorithm as well, many algorithms are proved based on the ideas of induction, all right? Induction is used very widely in mathematics and algorithms and all of that, okay? So yeah, that. In fact, in case of dominoes as well, it's the same thing, right? Ekta je dominoes, ei pura series ta jokhon arrange koro, what do? You make sure that if the first tile falls, the second tile will fall as well. That the first tile, you make sure basically that the first tile will drop the second tile. That's what you prove. And then you prove that if one tile falls, then the next one will also fall. And combining these two, you can establish, you can prove that all of the tiles in this entire series, all of them will fall. All right.
Ma'am, final question.
Yeah.
Is there any relation between inference and induction? Like
No.
rules of inference. So I guess isn't it like similar like to what you've said?
Similar in what way?
Like I have one thing and then I can like did the second thing and then I can
We're
say that
talking about inference being a parent set. Yeah, you can call it that way. That inference is the generic idea, general idea, and induction is a bit more specific. Yeah.
okay, ma'am.
If you're saying something like that, yeah, you can say that. They are not exactly the same thing, but inference is the parent class. You can think of it that way. That is, inferent is the parent idea, and induction is a part of it. Yeah. Induction is more specialized, you could say. Yeah. But they're not exactly the same thing. But yeah, induction is a part of the concept of inference. Yeah. Okay. All right then. So let's say we have a propositional statement Pn for some positive integer n. Pn being a propositional statement for some positive integer n. In order to prove that this statement Pn is true for all the integers n, using the rules of induction, ordinary induction, we have to prove in the basic step that the propositional statement is true for n is equal to 1. That is what you have to do. And in the inductive step, you have to prove that if the propositional statement is true for some integer k, it is also true for the next integer k plus 1. That is, this is something that we are allowed to assume. For every positive integer k, we can assume that if pk, we can assume that pk is true. And based on that assumption, we have to prove what? আমাদেরকে prove করতে হবে কোনটা? Prove করতে হবে হচ্ছে গিয়ে for the next integer. All right? The basic step where you prove for the first step, for remember the staircase, the first step is P1. The fact that you can climb the first step is P1. The fact that you can climb the next step, given that you are at any given step, is Pk to Pk plus 1. If Pk is true, then Pk plus 1 is true. That is what you have to do. Assuming that Pk is true, you have to prove that Pk plus 1 is also true. That is, the proposition is true for the next integer. And if you can do that, it means that the proposition is true for all positive integers n. Okay? Obviously, because if we prove this one, basic step jodi prove korte pari and inductive step jodi prove korte pari, dutake combine korle ki hoy? P1 is true, we know. K equals to jodi 1 hoy, then P2 is also true. Okay? Since we have proved the inductive step. And if P2 is true, P3 is true. P3 is true, P4 is true. You go on until Pn. So it will be true for all integers n by combining these two. Does it make sense how induction works? Guys. Silence. What does that mean? You guys get it or utterly confused?
Let's
Sinking.
repeat that again.
Sorry, Shafai?
It needs to sink in first.
All right. But is there any specific part that you are not comfortable with here? How induction works? Yeah. I understand what you say if you say that, okay, it's a little bit irksome, the idea that, okay, I mean, how does it work? In the middle, we are just assuming that everything is being taken care of. How does that work? But it actually does work if you think about these two steps, the combination of these two steps. If you could think about the combination of these two steps, it makes sense that it would work. If you have n number of integers for which you have to prove the statement, and jodi ei duta step, if you are capable, if you successfully prove these two steps, what does that mean? The statement is true for the first value, 1 er jonno true, and also you have proved that if the statement is true for some integer k, it's true for the next integer as well. Now, but combining these two, what can we say? P1 er jonno true, we have already proved that. If we do prove that, arki, P1 er jonno true, we proved that. And then, what is the next step? P2, Pk plus 1, 2. So P1 er jonno true hole, if you prove the inductive step, it means that it's also true for P2. If you prove the inductive step, it means that k is equal to 1 er jonno, here you have P2. So it's true for P2. Now, P2 is true. Again, feed that value back here. K is equal to 2. So it's true for the next one. So AJ, by combination, this is the basis and this is the process of induction. That is going to the next one. Just like that, you can go up to n integers and prove the entire statement for all n positive integers. Okay. Let's do an example. Let's prove something using induction. We are asked to prove this identity, that the summation of the n positive integers, the summation of n positive integers is equal to n into n plus 1 by 2. 1 plus 2 plus 3 plus 4 plus 5, so on until n basically. The summation of the first n positive integers can be represented using this expression, n into n plus 1 by 2. We have to prove this. Okay. What is the basic step? The basic step
N
is
plus
proving
1.
this for 1.
Pairs of n plus 1. Yeah, like n plus 1 তারপরে n minus 1 plus 2 এরকম ভাবে আর কি, যে গাউস যেভাবে আর কি.
No, we are not going to use the Gaussian proof. No, we won't. That's one way. That's one way of doing it.
Is it like the arithmetic series?
Yeah, that is the arithmetic series, but we will prove this using induction, not Gaussian. The Gaussian proof to use korbo na. That's a very interesting proof as well from folklore, but we will prove this using induction. Okay, not just Gaussian, there are many other proofs as well. এটা তোমার কি বলে triangular number দিয়ে proof করা যায়, অনেক 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 proof
হ্যাঁ
আছে।
ম্যাম, এটা এগুলো ট্রায়াঙ্গুলার নাম্বার। হ্যাঁ, ওই যে ট্রায়াঙ্গুলার নাম্বারগুলোর ট্রায়াঙ্গুলার নাম্বারটাকে এভাবে এক্সপ্রেস করা যায় 1 3 6 10 15।
So এই সিরিজটা বেসিক্যালি অনেক 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 প্রুফ আছে, এখানে we will prove it using induction. Okay, just to show you, demonstrate to you the steps of induction to prove some identity, how to do that. So induction we have two steps, right? We have to prove two steps, basically the basic step and the inductive step. Basic step e proof korte hobe that the proposition is true for the lowest value. The proposition is true for the lowest value of n. What is the lowest value of n here? The
1
lowest value of n here is 1, exactly. So you have to prove the proposition for 1. So what is p1? P1 from the left hand side gives us what?
1.
1, just 1. n এর value 1 মানে কি? It starts and stops at 1. And on the right hand side, what do we get? 1 multiplied with 1 plus 1 divided by 2. That also gives us 1. So left hand side equal to right hand side for n is equal to 1. That is the basic step. You're done with the basic step. There, done. What is the inductive step? The inductive step is to prove that if pk is true, then pk plus 1 is true. So we are allowed to assume that pk is true. What we have to prove is that if this is true, then pk plus 1 is also true. Okay. Now, what is pk for this entire identity? What is pk for this entire propositional statement?
yeah
pk left hand side. What happens to left hand side for pk?
It's like 1, 2 through k.
Yes, exactly. 1 plus 2 plus 3 so on until k. Right hand side, what happens to right hand side? K into k plus 1 by 2. So basically this is pk, right? This line 1 plus 2 plus 3 plus 4 so on until plus k on the left hand side, and on the right hand side k into k plus 1 by 2. This is pk, right?
Yes, ma'am.
Okay, so we can assume that this is true in the inductive step. What we have to prove is that pk plus 1 is also true. That is the one we have to prove. If pk is true, then pk plus 1 is true. So we can assume this is our hypothesis that pk is true, and based on this we have to move to pk plus 1. Now for pk plus 1, what do we have on the left hand side?
It's just up to k and then k plus 1.
yes
Exactly. So the last number will be k plus 1. So basically a expression if we add k plus 1 on both hand sides, then the left hand side is what we would have in the left hand side of pk plus 1, right? So what we have to show is that for pk plus 1, we have to show that 1 plus 2 plus 3 plus 4 and so on until k plus 1 is equal to what? K plus 1 multiplied with what? K plus 2 is divided by 2, right? n এর জায়গায় k plus 1 বসাবো, basically simply that, right? এখানে n এর জায়গায় k plus 1 থাকবে, এখানে k plus 1 আর এখানে k plus 2. K plus 1 multiplied by k plus 2 divided by 2. That's what we'll get on the right hand side, right?
yes
Yes,
ma'am.
ma'am.
Okay, so what we do is আমাদের যে hypothesis which we are allowed to assume to be true, this is true. So what we'll do is we'll add k plus 1 to both hand sides. Okay, so if we add k plus 1 to both hand sides, it's still correct. We haven't done anything illegal. If this equality holds, then donota side আমি same number add করলে it's fine, right? Equality both sides we are allowed to add the same number, right?
It's like sum till k and then add k plus 1. It's the same
Yeah,
thing.
but why did we do that? It I'm the reason I'm talking to you about this is that for you to figure out what to do when you have to prove something using induction on your own. So this is what we are allowed to prove. We have to prove from this assumption, we have to prove that 1 plus 2 plus 3 plus so on until k plus 1 is equivalent to what? K plus 1 into k plus 2 divided by 2. So এইটা যদি আমাদের hypothesis হয়, this is something we are allowed to assume. Now a equality dono side, if we add k plus 1, have we changed anything, guys? Change করেছি necessarily? No. Equality dono side, if you add the same number, it's still the same equality. You haven't changed anything. It still holds, all right? You haven't made any changes yet because you've added the same number on both sides. But what is the purpose of doing this? The purpose is to make the left hand side the same as pk plus 1. So now that we have k plus 1 on the left hand side, what do we have to do? we have to convert this right hand side into what? K plus 1 into K plus 2 divided by 2. All right. So here, by adding K plus 1 on both hand sides, on the right hand side you have this, and from here if you take K plus 1 in common, what do you get? K plus 1 ekhane theke first term theke commonly you get K by 2, and from this if you take K plus 1 in common you get 1. Okay, what is that? K plus 2 divided by 2. So K plus 1 multiplied by K plus 2 divided by 2. So understand the process. এই যে এখানে যে তিন লাইনের যে ইয়াটা এই ডেরিভেশনটা এটা তো মানে একটা ক্লাস 5 এর বাচ্চা এটা বুঝবে। That's not the problem. Understand the process. So in the inductive step we are allowed to assume that pk is true. So this equality is true. In the inductive step we are allowed to assume that. What do we have to prove though? Proof korte hobe pk plus 1 is true. Pk plus 1 ki 1 plus 2 plus 3 plus so on until k plus 1 is equal to K plus 1 into K plus 2 by 2. That is what we have to prove. So, otar jonno ami ki korlam? K plus 1 added to both hand sides, because if we add K plus 1 to both hand sides, the left hand side becomes what? The same as the left hand side for PK plus 1. And we are allowed to do this since we are adding this to both hand sides. So this, see, 1 plus 2 plus 3 plus so on until K plus 1. K plus 1 er ager number to K hi hobe, right? So this is the same thing that you would have in the left hand side of PK plus 1. Now what we have to do is এই যে এইখানে যে টার্মটা আছে এটাকে কনভার্ট করতে হবে into this term. So that's what we did. This, which is pk plus 1. So we have this left hand side equal to this, which is in fact k plus 1, pk plus 1. If we add k plus 1 on both hand sides, we get this equality, which is in fact pk plus 1. So we have shown that if pk is true, then pk plus 1 is also true for every positive integer k. So basically, since we have proved the basic step and the inductive step, we can say that Pn is true for every positive integer n by the principle of mathematical induction. Any questions?
No, miss.
Okay, so another way of looking at mathematical induction, remember in the basic step, you have to prove it for the lowest value. All right. Here, for example, in case of ordinary in case of ordinary induction, in the basic step, we prove it for 1. Why? Because, for example, in this case, what is the lowest value of n? 1. So basically, you prove it for 1 because the lowest value of n is 1. But the basic step, however, is to prove it for the lowest value. So let's say, for example, you have a statement about integers n where n is greater than or equal to b. All right. For some integer b, n is greater than or equal to b. That is, the lowest value of n is what?
B.
B, exactly. So that means that in the basic step, you do not necessarily have to prove the statement for 1. You have to prove it for b. Always in induction, in the basic step, we prove it for the lowest case. We prove it for the lowest case of n, okay? If it's 1, you prove it for 1. If it's some other integer b, you prove it for b. Here, we're talking about some statement Pn where n is greater than or equal to b. So the basic step is proving the statement for the value b. And in the inductive step, we prove the same thing. We assume pk is true, and from that we have to prove that pk plus 1 is also true, where k can be any integer greater than or equal to b, obviously, because b is the lowest possible value. So that would prove that the statement is true for all integers n where n is greater than or equal to b. For example, let's look at this one. 2 to the power of n less than n factorial for every integer n with n greater than or equal to 4. We know that this is true, but we have to prove that 2 to the power of n will be less than n factorial. 2 to the power of n will always be less than n factorial for every integer n with n greater than or equal to 4. Here, what is the lowest value of n, guys?
4.
4. 4 is the lowest value of n, correct. So if we want to prove this by induction use kore jodi proof korte jai, basic step e what do we have to prove? We have to prove this statement for n is equal to 4. We have to prove Pn for n is equal to 4. So P4 is what? 2 to the power of 4 and 4 factorial. Left hand side you have 2 to the power of 4 and right hand side you have 4 factorial. Is 2 to the power of 4 greater than or less than 4 factorial? Which one?
Less.
Less. You can, since it's a concrete fixed value, you can just calculate it and you will see that 2 to the power of 4, once you calculate it, you'll see that the value is less than 4 factorial. So obviously that makes it true. Okay. So the basic step is proved, right? Just by calculation. Now in the inductive step, what do we have to do? We have to prove that if pk is true, then pk plus 1 is true. We can assume that pk is true. From there, we have to prove that pk plus 1 is true. What is pk for this statement, guys? For any k greater than or equal to 4, what is pk?
2 to the power k less than k factorial.
We can assume that this is true. We can assume that 2 to the power of k less than k factorial is true. What do we have to prove? pk plus 1. What is pk plus 1?
2 to the power k times 2.
2 to the power of k plus 1.
No, 2 to the power,
Yeah, it's the same thing. Yeah, it's the same thing. So 2 to the power of k plus 1 or 2 to the power of k times 2 is less than what?
Less than
K plus 1
k plus
factorial.
1 factorial.
K plus 1 factorial. Exactly, correct. So yeah, so we can start with the assumption that 2 to the power of k is less than k factorial indeed. We can assume that this is true. From there, we have to prove that 2 to the power of k plus 1 is less than k plus 1 factorial. Okay. Now, based on what one you guys said, so we have this here. So on both sides, if we multiply 2, will this statement change? যদি দোনো সাইডে 2 মাল্টিপ্লাই করি, এই স্টেটমেন্টটা কি চেঞ্জ হবে? This less than statement will change.
Yes, ma'am.
Here,
Yes.
the less than statement will change. What will happen? It will become equal to or greater than.
Ma'am, for the right hand side, we shouldn't
No,
be,
miss, it wouldn't change. I don't think so. Why would it
we have
change?
to multiply with k plus 1 on the right.
No, you don't have to. What you have to do, you think. But I'm just asking that if you multiply 2, if we multiply 2 on both sides, এখানে যদি 2 multiply করি, এখানে 2 multiply করি, একটা
Yeah, no, it won't change. It won't change.
It's the same. থাকতেছে
Yeah, the value, like
it remains
the-
the same, right?
the condition wouldn't change. Yeah.
Yeah, the condition wouldn't change.
ফ্যাক্টোরিয়ালে তো জাস্ট এই যে মানে ইনক্রিমেন্টালি ইনক্রিজড হচ্ছে মাল্টিপল গুলার 4 into 5 into 6 যেখানে 2 এর সাথে এখানে নিজের সাথে মানে লাইক 2 এর সাথে বারবার নিজের মাল্টিপ্লাই হচ্ছে, সো এখানে 2 মাল্টিপ্লাই করলেও তো সেম থাকতেছে।
ফ্যাক্টোরিয়াল যেটাই হোক না কেন, একটা ইকুয়ালিটি বা ইনইকুয়ালিটি এখানের মধ্যে what you are doing,
বোথ সাইডে সেম থাকতেছে, সেম
both
ভাবে
side you are multiplying a positive value. নেগেটিভ হলেও তাহলে একটা কিছু চিন্তা করা হতো। একটা পজিটিভ ইন্টিজার মাল্টিপ্লাই করতেছো on both sides of inequality. It will not affect the inequality at all. That is
নেগেটিভ বলে উল্টা হতো।
হ্যাঁ, নেগেটিভ হলে একটা ঝামেলা হতো, but this is a positive integer. This 2, if you multiply it on both hand sides, what happens? You have 2 to the power of k multiplied with 2 less than k factorial multiplied with 2, right? Does it make sense? 2 to the power of k multiplied with 2 less than k factorial multiplied with 2. Correct, right? Okay. Now 2 to the power of k multiplied with 2. What is that? 2 to the power of k plus 1. Right? 2 to the power of k multiplied with 2. Here you have 2 to the power of k and here you have 2 to the power of 1. What do you get? 2 to the power of k plus 1. দুইটা power কি added হয়ে যাবে না? When the base is
Yes,
same,
yes.
do the powers not get added? Yeah. Basic math. So 2 to the power of k plus 1, you'll get that on the left hand side. On the right hand side, we have 2 multiplied with k factorial as before. Now see, the left hand side is the same one that you would get for pk plus 1, right? pk plus 1a, 2 to the power of k plus 1 would be there in the left hand side. Here as well, we have 2 to the power of k plus 1. So that is the reason we multiply 2 on both sides. That is the reason, okay? 2 can I multiply করলাম so that I can make the left hand side of this statement the same as k plus 1. Now
So
the right
now
hand
we
side,
have
yes, now we have to transform the right hand side into what? K plus 1.
factorial.
Exactly. Now to do that, first see, remember that k will be greater than or equal to 4, all right? K is always greater, k is going to be greater than or equal to 4. See, n will always be greater than or equal to 4, so k will also be greater than or equal to 4. So remembering that, will 2 not always be less than k plus 1? What is the lowest value of k? Lowest possible value of k?
4. So 2 is less than 5.
2 will always be less than k plus 1. Okay. So if that is the case, now this 2 to the power of k plus 1 is already less than 2 into k factorial. If it's less than this, it will definitely be less than k plus 1 into k factorial, right? If 2 to the power of k plus 1 is less than 2k factorial, will it not also be lesser than this? This is already a smaller value compared to 2k factorial, 2 into k factorial. Now we've established that 2k factorial is less than k plus 1 into k factorial. Why? Because 2 is less than k plus 1. 2 is less than k plus 1. So 2 into k factorial will definitely be smaller than k plus 1 into k factorial, right? Does it make sense, guys? If 2 is less than k plus 1, 2 less than k plus 1 mane ki? Think about the 2k factorial, this term. On these two sides, left hand side and right hand side, dono side you have k factorial. What is the only difference? Difference hochhe ki 2 and k plus 1. If 2 is less than k plus 1, 2 into k factorial will be less than k plus 1 into k factorial, right?
Yes, ma'am.
If that is the case, then 2 to the power of k plus 1 is already less than 2k factorial. If it's less than this, it will definitely be lesser than this term as well. 2 to the power of k plus 1, which is lesser than 2 into k factorial, will be lesser than k plus 1 into k factorial, because 2k factorial is already lesser than this value. Okay, so 2 to the power of k plus 1 is actually less than k plus 1 into k factorial. Can we not say that 2 to the power of k plus 1 is less than k plus 1 into k factorial? Think about it.
Yes, ma'am.
Yes, ma'am.
What is k plus 1 into k factorial?
K plus 1 factorial.
Exactly, k plus 1 factorial. If you expand k plus 1 factorial, what do you get? K plus 1 into k factorial. So this is actually k plus 1 factorial. So finally, we have proved that 2 to the power of k plus 1 is less than k plus 1 factorial. We started from the assumption, and then we got here where 2 to the power of k plus 1 is less than k plus 1 factorial, which is actually our pk plus 1. So we started from the assumption, and then we got to the conclusion where we have proved pk plus 1. So if pk is true, then pk plus 1 is also true for every integer k where k is greater than or equal to 4. And since that is true, we have proved the basic step, we've proved the inductive step. So by the rules of induction, we can say that the statement is true for all positive integer n where n is greater than or equal to 4. For all integers n where n is greater than or equal to 4. Any questions?
Miss, I didn't exactly understand the last one you said.
Which
The
part?
After 2k factorial is less than k plus 1 into k factorial. After that, I didn't understand.
Okay. Do you understand that 2k factorial will be less than k plus 1 into k factorial?
Yes, miss.
Okay. Now, this is something. Do you understand this part? That 2 to the power of k plus 1 will be less than 2 into k factorial. Do you understand this one?
Yes, miss.
Okay. এখন 2 to the power of k plus 1 যদি এটা থেকে কম হয়, 2k factorial থেকে ছোট হয়, and this value is lesser than who? K plus 1 into k factorial. Then 2 to the power of k plus 1 will also be lesser than k plus 1 into k factorial, won't it?
Yes, miss.
So 2 to the power of k plus 1 is less than this value, and this value is less than k plus 1 into k factorial. So this will definitely be lesser than this one, right?
Yes,
এটা
miss.
কোনো confusion আছে?
হ্যাঁ, মিস, এবার বুঝতে পারছি।
Okay. So k plus 1 into k factorial is what actually? K plus 1 factorial. K plus 1 factorial কে expand করলেই তো এটা পাওয়া যায়. So 2 to the power of k plus 1 is actually less than k plus 1 factorial. Is that clear now?
Yes, miss.
Okay. So that's the inductive step proved, and combining the basic step and the inductive step, we can say that by the rules of induction, Pn is true for every integer n where n is greater than or equal to 4. Okay? Any questions? Okay, let's end the session here and pick up from divisibility in the next session, day after tomorrow. So we'll start from divisibility day after tomorrow. All right, and I'll stop the recording here if there are no questions.